Hello everyone, welcome to my channel. A few months ago, Amazon OpenSearch has released their latest feature. It's called Vector DB Serverless. The most important thing is the serverless. Serverless means you don't need to maintain a host to run your OpenSearch engine. Maintaining a dedicated host is very costly, and it's a huge saving for some smaller developer. And Vector DB, as you may know, is basically a kind of DB, while the index is usually a vector. And this native supports the machine learning, for example, semantic search, RAG, retrieval augmented generation with large language models, and recommendation engine. And also, you can aggregate this vector DB with multimedia support, for example, image, audios, and videos. And today, I would like to show you how to create an actual vector DB in less than 10 minutes and how to aggregate some interesting method with this DB. So firstly, let's go back to the Amazon OpenSearch. So this is the landing page of Amazon OpenSearch. We want to go to the serverless section and go to the collection. So to create a new vector DB, you need to click the Create Collection button, and then you want to define the name of your DB. Let me name this DB as testdb-2, and you can input some simple description of your DB. And to use the vector search engine, you want to choose the vector search dash preview as the collection type, and then you can just choose the easy create as the security configuration. So this will use the default setting to create your DB. The default means for the encryption part, it will use the AWS KMS, and for the network access, it will just be the public. And the data access. So the data access, we will talk to that later, but it's just define the access of all the data in your DB. And you can choose to click Next. And to save some time, I have already created a DB. It's here. Let's look at it. So this DB is called test-vector-db. And as you can see, the status is active, which means I can now access this DB. So the first thing we want to check is the vector indexes. As you can see here, we already have one index in this DB. It's called test-index. But no worries, we will create another one from scratch. And the next section is the endpoint. So as you can see here, this is the URL of the DB endpoint. The DB endpoint is the URL you want to access to this DB. So basically, you send put, post, get, request to this DB, to this URL, and it will just make things happen. And unfortunately, this new DB doesn't support the OpenSearch dashboard yet. And the next thing is the network. So the network, we can see the access tab here is public, which means we don't need to use any VPC. We can just directly access this endpoint through network, internet. And the next thing is the encryption. So I created this DB, use the easy encrypt. So we just use the AWS KMS as the encryption key. And the next is the data access. Let's check the data access really quick. So as I said, this data access is actually define the policy of who and how can they access the data inside your DB. So it mainly contains two parts. The first part is the principals. So the principals is actually the entities who can access this DB. So as you can see here, I define two roles or users. So the first users is the user I'm currently using. And another row, this row will be the row I assume to access this DB through my runtime. And the next part is the permission part. So basically, I grant all the permission to these users. So I grant the collection and index to this user. So the users or the principals can create, delete, read, and write both collections and index. And this is a very important thing you want to make sure before you can like create rules or access your DB. And now let's get started. So I will use SageMaker Notebook to access this DB. So I'm now here at the home landing page of the Amazon SageMaker, and I will use the notebook. And I'm already running a notebook instance. So here's my notebook. And so the first step is I gonna install some dependency. The dependency we use today is OpenAI and OpenSearch-py, which supports the OpenSearch engine. And then I will import OpenAI and grant this OpenAI an API-key. So the API key, don't worry, this is just a temporary key. I will remove it later. And by the way, what is OpenAI doing here? So we want to use the embedding model from the OpenAI. Embedding basically just transfer a message, a text into a vector. And then we use that vector to store our message into the vector DB. Okay, so then I will import Boto3. Boto3 is kind of like a Python SDK under AWS. And what I'm doing here is I want to get the caller identity. So I want to make sure the row I'm assuming now, this is the row name, has a policy to access this vector DB. And let's go back to the vector DB configuration. Remember here, this is the data access page, and let's double check this row here has a permission to access this DB. Okay, so this step looks good. And now this line defines the URL. So how to get the URL of your vector DB is we can go back to the vector DB homepage and we get it here. We don't need to get the prefix. We just need to get anything after HTTP column // and here exactly the same. Okay, so the next thing is we set up the client to access this DB. Of course, you don't need to actually use this client. You can just directly send HTTP request, but that's kind of like a complicated way to do that. You need to configure credentials inside your HTTP header. And the easy way is we just utilize the client to do the work. So this is some authentication configuration we set up. And we define the port, we define the auth, and some connection configuration. And then this cells is creating index inside that DB. Let's look at it. So the first one, index name, is the name of index we want to create. Let me name this index as test index 2. Just want to make sure it doesn't collide with our existing one. Okay, looks good. And the data structure inside this index. So let's look at it. So the first thing is settings. Setting is the how do we want to set up this index, and we want to use the kn, and then the mappings. Mapping is kind of a data structure inside this DB. So the first column we want to have all the property is a vector. This vector's name is housing vector. Let me rename this actually. Let me rename this as text vector. And the type is kn vectors. And here is the dimension. So dimensions is something important you want to think about. So I put 1563 here because I already know the embedding model will return me an embedding with 1563 dimension. But for your application, these things varies like case to case. And then there's another property is called content. So the content is basically just the message we want to embed. And the data type is just test. Okay, so then we call the client to create this index with the index name and the index body. And let's run this. Okay, the response we can see here shared acknowledged true and acknowledged true, which means we have already created it. Let's check it in our DB homepage and refresh the page. Now, as you can see, the vector index is here. We have a new index called test-index-2. Okay, let's go back to the code. The next thing is we want to add some things into that index. So I'm using OpenAI to embed a message, a text, or we call prompt, into a vector, and we index the vector into that vector DB. So let's get some example. I will say search Facebook and get the V key from Facebook. So the first paragraph is just kind of like a description of the Facebook, and I copy it. I put it here, and here is our prompt. And we call OpenAI embedding model to embed this prompt, and we print the length of the embedding to figure out how many dimensions does this embed have. And then we define the body of the request we send to the vector DB. Here we need to rename this property name as the text vector we just defined. And the value is the embedding we just defined. And the content is the prompt. And then we call the client to index this body into our vector DB. Let's run the code. Okay, so this line 1533 is just the dimension number of the embedding. And you can see here, before that we have already defined the length or the dimensions of our vectors as this number. And then the response of index, you can see it succeed. That means we have added this prompt of this vector into our vector DB. And nextly, we want to search the relevant atom from this index. So what do? We firstly give a prompt. This prompt can be anything about Facebook. Let's see. Tell me about Facebook. And then we use the same mechanism to embed this prompt. We call OpenAI with the same embedding model to embed this prompt, and we get the prompt embedding, and we construct a query. This query, we first define the size. Size is just how many results we want to return. And inside the query, we define the index. So here, the index name should be text vector. And the vector values is the embedding we just have defined. And the k just the parameter of the knn. And we define it as 5. And we search it. Okay, so because for now, this index only have one atom, is the atom we just input. So of course, it will just return the content we just input. Facebook is an online social media, so this is exactly the prompt we just input. We just got it from the Facebook wiki. And now let's add more tests into this vector DB. So other than Facebook, let's do Apple. Oh, this is a vegetable. Let's do this one. The company. And then let's copy the description here. And run this cell again. And other than that, let's do more. Let's do one more. Maybe Microsoft. Okay, and copy and paste here. And run. Okay. And now let's try to query something inside this index. Let's see, tell me about uh, Apple. And run. And let's see. Okay, now the result we got, the content you can see is the description from Apple. Okay, yeah, so basically this structure can be scaled up. You can input like 10,000 in atom in your index, and it can also aggregate with multimedia search or RAG. So you can build a chatbot with this, and just remember to set up the correct dimension of the vector. And yeah, that should be it. I hope you enjoyed the video, and I will see you soon.